This semester, lecturers spent hours manually sorting student submission, checking timestamp, moving late files, sending warning emails. Today, I will show you how data flow architecture using Apache NiFi completely eliminates that problem. This is my software architecture assignment 2. The task is to choose a real-world problem involving movement, transformation, and processing of data, and also solving it using Apache NiFi. Let me walk you through what I built and show it running live. The problem I choose is assignment submission management. Without automation, a lecturer receives a file, manually checks the timestamp, decides if it's on time or late, moving it to the right folder, and send a warning emails if it's late. Multiply that by 100 students. It becomes a serious burden. This problem is a perfect fit of data flow architecture because it involves exactly what the assignment asks for, movement of data, which is file moving between folders, transformation of data, which tracking each file with its submission status, and processing of data, which is routing files and triggering notification automatically. Data flow architecture solves this by treating each file as a unit of data flowing through a pipeline, each stage doing one specific job. This system has 3 layers. First, the student web portal, a simple HTML form for submitting assignment. Second one is Python Flask API. Its only job to receive the file, check it the submission is before or after the deadline, and tag the file name with either online or late. That is all Flask does. It then drops the file into the folder NiFi is watching. Third one, and most important, this is Apache NiFi pipeline. There is where all data flow logic lives. Here in the Apache NiFi, you can see 4 processes: get file watch the submission folder and picks up every file class deposits, routes on distributes attribute treats the file name and makes the routing description. On time goes one way, late goes another way. Put file moves file correct destination, and put email automatically send warning to the lecturer for every late submission. None of this logic is written in application code. It all lies in the pipeline. That is the sense of data flow architecture. Let me show this live. I will start with an on-time submission. The deadline is set to May 2026. The green message confirms submit on time. Task received the file. Confirmed it was before the deadline and send it to the NiFi. What's the folder in the on-time prefix. So here you can see that file comes in the right in the that file has uploaded on time. In here you can see in 0 and out 1, and here you can see in 1. So the file appears in the grading folder. NiFi get file picked it up, route on attributes of the on-time prefix and routed it correctly, and full file moved it here automatically with no manual action from the lecturer. The file moved to the pipeline was tagged with its status and delivered to the right destination. That is data flow in action. The late submission path, I have set the deadline to the pass date to trigger this. So here you can see yellow warning, you are late. Then inform that Flask detect the submission exceeded the deadline and tag the file name with the late. The file appeared in the late submission. So you can see that. And in the Apache NiFi, the warning email arrived automatically and send the NiFi email processor with the file name in the subject line into the lecturer knows exactly who submitted late. No manual check-in, no manual sorting, so no manual written email. The pipeline handles everything. So, and also here you can see that late submission message. So 3 key features of this design worth highlighting. First one is attributing based routing. Route on attribute uses NiFi expression language to evaluate file attribution and direct each file down the correct path. Conditional logic built entirely in the configuration, so no code. Second one, built-in observability. NiFi automatically record the complete audit trail on every file, which so here like this loading, which processor handled it so every file which process handled it, what decision was made, and the exact timestamp, 0 additional code required. This is given the institutional and permanent record of the every submission received. Another thing is, third one is losing coupling. Each processor is independent. If I wanted to add a new destination save folder for these submissions, I add one processor and one connection, no application code change at all. So to summarize, assignment submission management is real-world problem involving movement, transformation, and processing of data. Apache NiFi data flow pipeline automates the entire process, routing on time files to grading, moving late files to separate folder, and notifying a lecturer automatically. The design demonstrates loose coupling, pipeline composition, attribute-based routing, and built-in observability without complex pipeline logic. So thank you for watching.